Good day. Our objective is to determine the equation of a line given the gradient and a point on the line. And we'll be determining the equation of the line in both slope-intercept form and standard form. So first, we will look at how we get the standard form formula. Let's consider a straight line. Let's say we know one of the points on the line and we don't know other points. We only know one point. If we were to look at it, we could say that the formula is, in general, y2 minus y1 over x2 minus x1 for the gradient. However, if we don't know the other point, let's ask ourselves the question, what would be the gradient from 1 to the point that we do know up to this unknown point xy? And would it be different from the gradient from 1 to the point that we do know up to this second point xy? Or from the point we do know to the third point xy? When we find those gradients, would they be different? Well, the answer to that question is no, they would all be the same. Why? Because it is one straight line. Since it is all going in one same direction, the gradient or the slope would be all the same between any 2 points. That is a key thing to remember. Since it is one straight line, the gradient from this point to that point would be the same between any 2 points. So in our formula, y2 minus y1 over x2 minus x1, we can replace the second point, y2 and x2 coordinates, with simply y and x. If we do that, then our next step can be to transpose. So instead of dividing by x minus x1, when we transpose it to the other side of the formula, we would multiply by the quantity x minus x1. And so here we have our formula for the equation of a line in standard form. When we want to calculate it, y minus y1 is equal to m times x minus x1. So let's get into our first example. We are to determine the equation of the line that passes through the point 3 minus 7 and has gradient 4 in both, first, slope-intercept form, and secondly, standard form. So whenever we work a problem like this, a good thing would be to first start off by drawing a sketch. So we know the point is 3, negative 7, and it has a gradient of 4. Since the gradient is positive, that means it slopes upwards like this. That is something we had to learn before already. So when we find the equation of the line in slope-intercept form, we already know the gradient is 4m. We want to find the value of the y-intercept c. So based on our sketch, we know it should be some negative number. So let's see what we get. So we start by writing our formula. In slope-intercept form, it is y equal mx plus c. So substituting our values that we have, the y-coordinate is negative 7, the gradient is stated as 4, and the x-coordinate is 3. Then we simplify. 4 times 3 is 12. Then when we transpose, instead of adding the 12, we will subtract the 12 from negative 7. So c is equal to negative 7, take away 12, which will give you negative 19. So the line crosses the y-axis down here at negative 19. And therefore, our answer is y equal 4x minus 19. Finding the answer now in standard form. We start by writing our formula, y minus y1 is equal to m times x minus x1. Substituting our values, our y1 value is negative 7, our gradient is 4, and our x1 value is is 3. So simplifying, y take away negative 7 will become y plus 7, and then expanding brackets, 4 times x is 4x, and 4 times negative 3 is negative 12. So I will transpose, and then I'll have y minus 4x is equal to negative 7 minus 12, and that gives me the final answer of y minus 4x is equal to negative 19. If you had gotten the answer in slope-intercept form, then it is very easy to get the answer in standard form as well by simply transposing the x values for most cases. Let's look at another example. Determine the equation of the line that passes through the point -9, 5 and has gradient -2/3 in both, first, standard form this time, and secondly, slope-intercept form. So let's start in standard form. We begin by doing a little sketch. So the point we know is -9, 5. And it has a gradient of -2/3. The fraction part doesn't matter that much. What is important for a sketch is that the gradient is negative, which means then that it will slope downwards. Remember, if the gradient is positive, it slopes upwards. If the gradient is negative, it slopes downwards. And if the gradient is 0, it is a horizontal line. So in slope-intercept form, we begin by writing our formula, y minus y1 is equal to m times x minus x1. Substituting our values, we'll have y minus 5 is equal to -2/3 times x take away -19. And then we simplify. So -2/3 times x will give you a -2/3 x. Then negative times negative is positive. Positive times another negative gives you negative. And then 2/3 times 9 is 6. So transposing, I'll have y plus 2/3 x is equal to 5 minus 6. 5 minus 6 is -1. And it would seem like this is our answer since we have the x and y on one side equal to a constant. But it is customary that your x and y don't have any fractions as their coefficients. We want only whole numbers as our coefficients for the x and y terms. So since there is a fraction here with a denominator of 3, what we do is we multiply the entire equation by 3. We multiply all terms by the number 3. So 3 times y will give you 3y. Then 3 times 2/3 would give you 2. And 3 times -1 gives you -3. So your answer is 3y plus 2x is equal to -3. In slope-intercept form, we begin by writing our formula y equal mx plus c, substituting our values. Y is 5, m is -2/3, x is -9. So -2/3 times -9 is +6. So when we transpose that, we'll subtract 6 from 5, and that will give you -1 as the y-intercept value. So y equals to -2/3 x minus 1 is our answer in slope-intercept form. And remember, in slope-intercept form, the gradient of -2/3 tells you how the line is sloping. So it is -2/3, which means that it slopes downwards, as told to you by the negative. And then the 2/3 tells you that for every 2 that it goes down, it goes across 3. As you can see here visually, 2 down, 3 across, 2 down, 3 across, 2 down, 3 across. And then the y-intercept value being -1 tells you that the line crosses the y-axis at -1, as we can see here from our sketch. So, if you understood that, let's practice on these two. Number 1, determine the equation of the line that passes through the point 3, 4 and has gradient -5 in both slope-intercept form and standard form. And secondly, determine the equation of the line that passes through the point -10, -1 and has gradient 1/2 in both standard form and slope-intercept form. So pause the video at this point, work them out, and when you are finished, you continue in 3, 2, 1. Here are the answers. So if you liked this video, please give it a thumbs up and subscribe. And I think you will also like these other videos as well. Maybe give them a try.